Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, Duggan, and I'm joined by Sana. We're broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time or 1 a.m. Universal time for EDT. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. Go to www.yorku.ca/science/observatory and follow the links to OPV and join the chat. For any questions or comments you have of our past shows, or if you have suggestions for topics in the future, please send us an email at observe@yorku.ca. You can always connect with us on Instagram with the handle at Yorku Observatory and on Facebook at Allan Carswell Obs. All of our programs are free, but if you would like to make a donation, please see our website at yorku.ca/science/observatory. So, Sana, how you doing?
Doing pretty good. We've had an amazing week of clear skies. Uh,
Absolutely. So great.
yeah, it was really surprising actually because we had quite a few nights last week and then a few more nights this week of just like nice, pretty clear skies, which was I was not expecting that, but we've been taking full advantage.
Yeah, the group chat has been definitely active. I've been seeing some of the work.
Yeah, yeah, it's been a lot of fun. We've been running the 60 centimeter too, and also the 1 meter, so it's fun having both of the telescopes going again.
Yeah,
But
very glad to see the 60 back.
yeah, yeah. But how about you? How are you doing?
Good. Also taking advantage of the good weather, been trying to be outside as much as possible.
Mhm.
Some nice viewing opportunities for some upcoming events that I'll talk about in a little bit during the reminders, but taking advantage of those. I spotted the ISS the other day by accident.
Yeah.
Not wasn't even out looking for it, so that was cool. Yeah, work's work, school's school.
Yeah. I mean, that's the benefit of just, I guess, looking up whenever you're you're outside. Sometimes you will see something fun.
Absolutely, for sure.
Yeah,
Still
I
haven't been able to catch any Starlinks.
oh, okay. Yeah, we've got the Starlinks a couple times at the observatory and on the atrium tours. The atrium
Hmm.
tours are great for that because you're just, kind of standing there looking up at the sky for a while. So I've
Yeah.
caught them a couple times, but they're pretty neat. Like I know Starlink can be annoying for astrophotography, but it's pretty interesting to see like just some of these things just keep coming.
Yeah, the train of satellites.
Yeah, yeah, they'll just keep going and going and kind of every time you expect them to stop, there's still more.
Yeah, very cool.
Yeah.
Yeah,
Yeah.
definitely a pain for imaging though.
Oh yeah. Yeah, we get the Starlink satellites zipping by images all the time. Um,
Yeah,
but it can be interesting to watch just by eye.
for sure.
Yeah. So I think it is actually clear at York, so hopefully we will have a little bit of live observing a bit later on. Um, it's just still a little bit too bright out. These stupid 9 o'clock sunsets.
Yeah. I think we have some clouds rolling in from the west, but very slowly. It's like a really light cloud cover, but it looks to be staying at bay for now.
Yeah. Hopefully we'll just have an hour of clear skies so we can do some live imaging on the OPV, and then we can
That would be amazing.
yeah.
All right. Do you want to start us off with our first history item?
Sure. So this is July 29th, 2005. So today exactly was the anniversary of the date that dwarf planets Eris and Maki were announced. Both Eris and Maki had been discovered previously, but the announcement was only actually made a few months later on July 29th, 2005. I know Eris and Maki are two dwarf planets in the Kuiper belt. And these were some of the very first dwarf planets in our solar system to actually be discovered. So a little bit of information on what a dwarf planet actually is these are things that fail one of the three criteria for an object to be considered a planet in our solar system. Now, the International Astronomical Union has this set of criteria where planets in the solar system have to be objects that orbit the sun. They also have to have enough mass to be more or less spherical in shape. And with the criteria that's the issue for dwarf planets is they have to like clear their orbital pathway. So in other words, they have to be the most massive body in their orbit around the sun. And this is the place that dwarf planets like Eris and Makemake fail. They are spherical, they're massive enough to be spherical, they orbit the sun, but they sort of cross over into the orbit of other planets, so primarily Neptune for the case of Eris and Makemake, which means they actually cannot be considered planets in terms of the IAU definition. Now, Eris and Makemake were both discovered by astronomers in the same group, which included astronomers from the California Institute of Technology, the Gemini Observatory, and Yale Observatory. And they were both discovered in observations that came from the Palomar Observatory. So, a couple just quick facts about Makemake and Eris. Makemake is the second brightest Kuiper Belt object, with Pluto being the brightest. It has an orbit of 305 Earth years and is named after the Rupuni god of fertility. Makemake also has a small moon in orbit called MK2. And just a quick fun fact about Makemake when it was discovered, because it wasn't immediately announced, the astronomers who discovered it used code names to talk about Eris and Makemake. So they could kind of talk about these dwarf planets without people realizing what they were talking about. So Makemake had the code name Easter Bunny because it was discovered in March of 2005, which was kind of around Easter. In terms of Eris, this was also discovered on the Palomar Observatory in 2005, except it was discovered in archival data that had actually been observed in October of 2003. So this is another one of the great discoveries to come out of archival data at telescopes. Eris itself is about the same size as Pluto, but it's about 3 times further away from the Sun and has an orbit of 557 Earth years. It was originally nicknamed Xena when it was discovered, but was ultimately named Eris after the Greek goddess of discord and strife. Like Makemake, it also has a moon called, but this time it's called Dysnomia. In terms of what Eris itself actually looks like, it's a sort of nitrogen rich ice on the surface and is very cold, around minus 200 degrees Celsius. Now, aside from just being interesting objects in their own rights, Eris and Makemake are pretty important in terms of the actual IAU definition of what a planet is. So in 2005, at the time these objects were they were discovered and the discovery was announced, Pluto was still considered a planet by the International Astronomical Union. And it was really the discovery of Eris and Makemake that triggered this discussion of whether or not Pluto should be considered a planet. The original reason for that discussion was because when they were discovered, astronomers believed that Eris was bigger than Pluto. So it kind of begged the question of how can we consider Pluto to be a planet and Eris to be a dwarf planet? And kind of where do we start drawing the line between planet and dwarf planet? Because it's kind of ridiculous to have a solar system with like hundreds of planets. There's a whole bunch of these dwarf planets that have been discovered, and there had been more that were continuing to be discovered. So you can't really start calling all of these smaller objects in the outskirts of the solar system planets. And it was really because of that discussion that the IAU went and defined those 3 different criteria that reclassified Pluto as a dwarf planet instead of a planet. I do want to point out that even though it was originally believed that Eris was bigger than Pluto, we now know that this is not the case. Pluto is actually bigger than Eris. I think it's the biggest Kuiper Belt object and the biggest dwarf planet. But nonetheless, it was really that the discovery of these 2 that triggered that discussion and resulted in the reclassification of Pluto in August of 2006. So very interesting objects that were discovered, really interesting sort of history behind this reclassification of Pluto. But unfortunately for any Pluto lovers, I guess you might not celebrate the discovery of Eris and Makemake because of the implications for Pluto.
Man, Pluto had it really great until these guys came along.
Yeah.
Um, yeah, I would be upset too if I was a Pluto fan.
Hmm. We
But
know a
yeah,
Pluto fan who is very upset by this.
yeah, I don't, yeah, she would be so mad. I know she has them like Eris, Makemake, they're on the enemy list for sure.
Yeah. Yeah, I
All
don't know.
right.
I know it's still interesting that a lot of people disagree with the reclassification of Pluto, but um it makes sense from this standpoint, but it was kind of unfortunate that Pluto was declassified.
Yeah, and it does make sense though, because there are other similar objects in the asteroid belt, that like Ceres,
Hmm.
that were initially considered like planet adjacent. And then when people, because they are like, Ceres is pretty round, if I'm not mistaken. It's like round. Um, and it's pretty big, but it's not big enough to clear the field at all. And it's got like troops of asteroids following it.
Yeah.
So, I mean, it really just can't be considered a planet in that way. Although it's interesting to me that clearing the orbit is like, moons are an exception to that. But I guess that would signify that it's big enough to have its own orbital, like things in its own orbit,
Hmm.
because we don't really have much else in the orbit.
Yeah. I don't know, the some of these definitions can might seem a little bit not super arbitrary because I can kind of think of reasons to back it up, but it sort of seems like they were just looking for the thing to declassify Pluto.
Yeah, but I
Well,
I uh I see what they mean.
yeah. And everybody still loves Pluto, so it hasn't changed the amount of love that Pluto's been getting.
Oh yeah, not after New Horizon. Like it'll still get the attention.
Oh yeah. Yeah. I mean, it has a heart on its surface.
Yeah.
It, how can you not love Pluto?
No, it'll get the attention for a while. I think it's gonna have to be like a generational lapse before people start only thinking of it as a dwarf planet, because like we've all been around for the transition, you know what I mean?
Yeah, yeah.
It's still, we're like, oh yeah, there's 9 planets in the solar system. Wrong.
Yeah, in our
Like
heart.
to me it's nine. That's what I learned in kindergarten. So
Mhm. Yeah, it'll take a bit of
but
time,
yeah.
but I guess people will eventually start just default referring to it as a dwarf planet. But
Absolutely, yeah. And the other thing about Pluto was like it crossing Neptune's path,
yeah,
which like complicates things heavily.
yeah, yeah.
Okay, so I'll grab our second history event. This is not too long ago. And this is July 30th, 2020. So right during the pandemic, the Perseverance rover was launched atop the Atlas rocket. So NASA's Mars 2020 mission was one of 3 major missions to Mars that were launched within that window. There was a pretty narrow launch window of about 2 months during the summer of 2020. And it was the last time that Mars was going to be this close for over a decade. So it was a pretty big opportunity for a bunch of space agencies to capitalize and send some tech over there. So along with the United Arab Emirates Hope Orbiter and China's Tianwen-1 mission, NASA decided to put together a mission. Um, and this was the Perseverance rover, as well as the Ingenuity helicopter, which launched from the rover. The launch was quite a story of perseverance in and of itself. Um, there was a really narrow launch window, and all of this was happening at the very peak of the COVID-19 pandemic. Everything was in lockdown. Of course, the rover's in a clean room, Ingenuity's in a clean room, the rocket's in a clean room, and it took a lot of work for NASA to make sure that everybody working on the rover and the entire project was still able to come in and get everything done in a timely manner. So it definitely put a bit of a hamper on testing and pre-launch activities. As you can imagine, all of us were at home and able to watch the launch, but everybody at NASA was still working and they had to go through some pretty strict regulations to make sure they could still work. But even with all that going on, NASA managed to launch the mission just 8 days later than the originally scheduled launch date within the ideal launch window, which is fantastic if we know anything about NASA launches. They're almost guaranteed to be a few months or a few years late. So it was really excellent that they were able to get this done within the launch window at such a difficult period in time. So if they didn't launch it then, it would have been a really long time to get another launch window that was as nice as this one. And the mission has been an excellent success. Its main mission objectives were establishing Mars as a habitable space for humans. I know we hear that a lot, but Perseverance has continued to try and find more habitable locations to make a base on Mars a lot easier. So it spent its time exploring the surface, looking for signs of habitability, seeking out biosignatures, and putting away samples of rock for later testing because it will be collecting samples for potential sample return missions. And it's also looking at oxygen levels in the atmosphere. Um, in addition to this, Ingenuity, which is a robotic helicopter aboard Perseverance, has had multiple successful launch and on Mars flights from the rover. So it launches from the rover and then comes back to the rover. So I believe Ingenuity has now taken its last flight, but it still ran far beyond its expected lifespan. So Ingenuity has been doing atmospheric readings, taking images from different altitudes, all within pretty close range to the rover. And overall, it was a very successful mission and continues to provide some solid data, which I think we're going to be talking about then. Actually, no, this rover that I'm going to be talking about is not Perseverance, but Perseverance is continuing to send back more work all the time.
Yeah, I remember watching the Perseverance launch. It was a really nice launch and perfect landing on the surface too. Um,
Oh yeah, super smooth.
yeah, the Ingenuity helicopter is probably one of my favorite parts of this mission
Yeah.
because it's such a cool concept, a cool idea to actually have like a flight on another planet. Um,
Yeah, I mean, just like the GPS tech of everything and it's communicating with Perseverance itself, like deploying from Perseverance, then coming back to Perseverance, all the while Perseverance is doing its own thing is super impressive. And
mhm.
definitely a huge step for potential things for if we ever do send a manned mission to Mars. That's more stuff that we can have done safely with tech rather than having, humans going up and trying to go to different out. We know we can send a helicopter now.
Yeah. Yeah, I think one of the other cool things is it just kind of highlighted how useful having a helicopter to work with the rovers actually is. Because I know Perseverance kind of it didn't really rely on Ingenuity, but Ingenuity was very helpful for things like scouting different location sites for Perseverance to go to. Like they did have satellite images of a lot of these locations, but it was really useful for the Perseverance team, to have this helicopter to just go and like scout out the location and take a look at what's actually there, what's going to be the most interesting scientific targets in the area. So even though that wasn't really what Ingenuity had been designed to do, it was just that sort of proof of concept uh, kind of mission. It was still really useful to even have that for Perseverance. So I guess a lot of future missions are going to include helicopters, just because we now
Yeah,
know.
and it was also just really nice to see. I know sometimes the images we get from satellites, okay, they're very far out. They're really zoomed out. And then the images we get from the rovers themselves are super close to the ground. And Ingenuity was a really nice medium to see what the geographic features look like from like 100 feet in the air, basically.
Yeah.
I think it might have been yeah, about 30 meters away.
Mm.
Um, and it just a kind of a better view of the terrain, see what might be some good terrain for Perseverance to study, what might be unsafe terrain, but you can't really tell on a satellite.
Mhm.
It was definitely a very valuable part of the mission.
Yeah. I'm really glad that it lasted for as long as it did. It kind of makes sense because NASA does have that habit of under promising and over delivering. Um,
Right.
I'm definitely very glad that it lasted as long as it did.
Me too.
And in other news, it has been 4 years since 2020. I
Which is, oh my God.
Yeah, it's kind of funny because like there's some things now. When I first started York Universe, I didn't really remember any of the This Week in History items. But now we're at a point where we can actually talk about like, yeah, there was this week in history item, and I remember being there for that launch and watching it, and or when that news was announced. Like I'm actually starting to remember this stuff now. So, um, oh my God.
Yeah, we were this went from something that we talked about on the news today, like 4 years ago, and now it's this week in history, which is crazy. And you
Yeah,
know what? There's a lot that we've even the big solar eclipse that happened, that was I think our first observatory event. I think if we're on an August um York Universe, we can talk about that as well
yeah,
because that was a crazy event. And now that was my first foray into astronomy outreach, and now that's become a history event. Like I think that was 2017 that happened, the summer of 2017.
yeah, yeah. I also kind of remember during that eclipse, we were talking about the 2024 total solar eclipse that you'll have to drive a couple hours away out of Toronto to get to, but we're gonna get a
Oh my
total
God, you're so right.
tour. And I remember talking about that, and it's like, and we actually did see the 2024 solar eclipse. Like that happened.
Yeah.
And that event is over now. But yeah, it's kind of funny now thinking back that we have actually hit some of these milestones.
Gosh, we're getting old.
I know.
Paul would kick us if he heard us talking like this, though.
Yeah, well,
He
Paul,
would,
we could use this as an excuse to get Paul back on the York Universe episode, as you need to tell us
yeah.
off about how we're getting old.
Paul, if you're listening to this, we need you back.
Yeah.
We need your anecdotes. We can't keep doing this. Everybody remembers what we're talking about. I, I, I need some valuable insight that's not from like 2 years ago.
Hmm. Hmm.
Even like I know the one that we're waiting for, and we've talked about this on the show before. The one that we're waiting for that's going to become like the biggest this week in astronomy news, and then this week in history event is going to be when Betelgeuse goes supernova.
My God, I'm so looking forward to that, but I don't know if we'll actually.
Yeah, we had that jump scare when everybody was talking about it because of its normal periodic like fluctuations.
Yeah.
Um, and then we got excited for nothing. I think we had two different shows about that, but I hope it's soon. I hope it's soon because I want to see it.
Yeah, it would be the thing that's kind of wild to me about that is like it's going to be so bright that you can actually see it during the day. So even if it happens
Yeah.
in the summer when Orion is below our horizon at night, like you're still going to be able to see this thing.
Yeah, we'll
For,
be okay. We'll be fine. Maybe
yeah.
we'll drive somewhere to see it at night. Although that's going to be I don't think we have to fly to Europe. Um, but this is like yeah, I would love to see it because it would be pretty bright. And especially at like dusk and dawn. Oh my God, it would be beautiful.
Oh yeah. Yeah. But one thing we do know is going to happen is T Corona Borealis. So even if we don't get Betelgeuse, we will hopefully have a nice bright something or other popping up in the sky soon.
When is that?
We sometime this summer, most likely. It's kind of dimmed a little bit, um,
Hmm.
and we're just sort of waiting for it to blow up. But I don't think there's super accurate estimates on when it's going to blow up because it's like it's hard to predict very accurately. But it's probably going to
Yeah.
be, yeah.
Yeah,
We've
you're
been
right. It said it.
sorry, go ahead.
Sorry, go ahead.
Oh yeah, I was just saying we've been periodically watching T-Core bore with the 1 meter. Every night we observe, we kind of sit on it for a couple hours to get some part of that light curve. And I'm just kind of we
Okay.
sort of joke around every time we're observing, like, what if this thing blows up while we're observing it? Like, wouldn't that be awesome?
Wouldn't that be awesome? But maybe would it fry the CCD
Oh, it would
or the
absolutely. It would the CCD would not have a fun time with that. Um,
no, like rest
but
in peace to the CCD. But it would be great.
yeah, yeah, we would just keep observing it, like, just flip to a different filter that's less sensitive and just keep observing T Corona Borealis until sunrise or until clouds happen.
Yeah.
Um,
You might need to put the solar filter on it.
oh my God.
Maybe
Yeah.
not that bright, but it would
Yeah.
be big.
It's definitely gonna be like a naked eye it will be a noticeable difference if you know the constellation.
Yeah, I'm seeing that it was like it's doing one of its cyclic fadings, which are usually they usually occur before the outbursts.
Yeah.
So, and it says it could be now between now and September. So, fingers crossed. Please call me into the observatory. I will drive all the way over.
Oh, I will if it happens, the group chat is probably going to blow up.
That's true. You're right. I would get the notifications. My phone would not stop.
Yeah, like your phone will just die. There'll be so many notifications going about that. Um, but I just really hope we actually have clear skies when it goes.
Agree.
Yeah, because that would
Yeah.
kind of
Do you do you want to kick off the next history item?
yes,
Or doing more
yes.
launches?
Yeah, so this is not a one specific date. This has to do with the Apollo 15 missions. So these missions last several days at a time. So this is sort of a couple of different dates in astronomy history. Starting off on July 26th, 1971, which was when the Apollo 15 mission launched. It launched from the Kennedy Space Center aboard a Saturn V rocket, as did all of the other Apollo missions. Much again, all of these Apollo missions have a similar sort of setup to them. So, like all of the previous missions, the crew consisted of three astronauts, including Commander Dave Scott, Lunar Module pilot Jim Irwin, and Command Module pilot Al Worden. The way that the Apollo 15 missions would work is that the commander, in this case Dave Scott, and lunar module pilot Jim Irwin would actually go in the what's called the lunar module and land on the surface of the moon, stay there for a few days, and then go back, launch, lift off of the surface of the moon to go back to the command module, where the command module pilot Al Worden would have been orbiting the Earth by himself for the entire time they were actually on the surface. Um, now, the one of the pretty unique things about Apollo 15 and one of the great things about it is that it was really one of the first sort of all-out scientific explorations of the moon. Before Apollo 15, a lot of the Apollo missions had been focused mainly on other things, like actually executing the first landing on the surface of the moon in Apollo 11, or doing the first pinpoint landing in Apollo 12, where they could actually pinpoint exactly where on the surface of the moon they were going to land. The first few Apollo missions definitely did a lot of really cool science. They brought the first samples of the lunar surface back to the Earth. But like I said, they're kind of focused mainly on other things, like actually doing the landing successfully and successfully doing moonwalks. But on Apollo 15, a lot of those sort of kinks had been worked out. This was not the first one, there had been several previous moon landings, so there was already a lot of experience from astronauts who had landed on the moon before, and also from the ground crews who had been working in mission control with the Apollo astronauts. So it really kind of left them a little bit more room to actually maneuver and learn how to do science on the surface of the moon. In particular, Commander Dave Scott felt it was very, very important to learn about lunar geology. So he really made that and lunar geology and doing science a key mission goal for Apollo 15. And for the very first time in any of the Apollo missions, incorporated geology and scientific training into the official training schedule for himself and his fellow crewmates. So it really was the first time that astronauts went to the surface of the moon with like a really one of the major mission goals was doing science and learning about the geology and history of the moon. On top of that, this was the first in what's called the J series of missions, which just included several different hardware upgrades that allowed the astronauts to do more on the surface of the moon. This included an upgraded lunar module where the astronauts would live while they were on the moon that would let them stay there for longer periods of time than had been previously possible. They also had upgraded spacesuits to extend the amount of time they could spend walking on the surface of the moon. and for the very first time included the use of these lunar roving vehicles, or moon buggies, which is kind of a cute name, which were basically just cars that they could drive around on the surface of the moon. This would allow them to travel much further distances than they had previously been able to if they had been walking, and also made it easier for them to carry stuff around the moon, like their experiments and, of course, the very important samples of rocks that they brought back to the Earth. So all of the astronauts, again, they had pretty extensive training in field geology, where they basically learned to think and talk like geologists. This would allow them to sort of be able to identify interesting geological targets on the surface of the moon while they were doing moonwalks, and also allow them to accurately convey this information back to the ground crews and the geologists who were working with the Apollo astronauts. So they were basically able to do a lot more science because they were changing the way that they thought compared to the other Apollo astronauts in the previous missions. Now, all of this training ultimately paid off massively during the mission. Scott and Irwin touched down on the moon on July 30th, 1971, in their lunar module named Falcon. They landed in this Hadley-Ryle region, which is in the Apennine Mountains area of the moon. Now, this was a kind of risky area to land on the surface of the moon because the terrain was a lot more rugged than had been in any of the previous landings. A lot of the earlier landings, especially the Apollo 11 landing, they picked locations on the surface of the moon that were relatively smooth, so there wasn't really anything astronauts could, run into while they were trying to land the lunar module. But with those several sort of trials and some actual experience landing on the moon, they decided to pick a riskier terrain because it had a really big scientific payoff. Scientists were hoping to find evidence of some of the moon's primordial crust at this location, which was ultimately why it was chosen. It's a bit of a unique area on the moon, and it was one of the best places to search for this primordial crust of the moon. In total, during the mission, Scott and Irwin did 3 moonwalks, in total spending 18 hours and 37 minutes walking on the surface of the moon, and traveled 17.5 miles in total, which broke records, a whole bunch of records at the time. During their moonwalks, they did some things that were very typical of all of the Apollo crews, including deploying the Apollo Lunar Surface Experiments package and collecting a whole bunch of samples. This included the deepest core samples that had ever been collected up until that point, which in total had 42 different layers. Now, I'm not a geologist. I don't know if this is actually a lot, but this definitely seems like a lot of layers to me. So it was pretty shocking when I read that their core samples had 42 different layers. On top of that, they scaled the side of the Hadley Delta mountain and visited Spur Crater, where they took more interesting samples, including what is probably the most famous of any of the rocks collected during the Apollo missions, called the Genesis Rock. This is believed to be a part of the moon's primordial crust, with the rocks dating back at 4.5 billion years old. So exactly what scientists had been hoping to find at this location, they actually did find on Apollo 15. Another interesting thing that they found were the first records of lunar volcanism preserved where they formed. So previously in all of the other Apollo missions, when they did find evidence of volcanism, all of this volcanism was sort of these rocks that had been scattered as pieces during some sort of impact. But at this location for Apollo 15, they actually found lunar volcanism preserved where it was formed without having another sort of impact that scattered any of that material anywhere. So another really interesting scientific result that came out of Apollo 15. There was also a lot going on in the command module Endeavour during this time, where astronaut Al Worden was doing things like looking for evidence of volcanic gases on the moon using different sensors aboard the command module. And he also released a satellite into lunar orbit that was equipped with a magnometer to search for evidence of a lunar magnetic field. So definitely a lot of science happening both on the surface of the moon and in the command module, and was a pretty groundbreaking mission in terms of learning about the history of the moon. Now, in total, astronauts spent 67 hours on the lunar surface, which was the longest of any of the Apollo missions at the time. And then the lunar module lifted off of the surface on August 2nd, met back up with the command module in orbit around the moon, and then eventually returned to the Earth after spending a little bit of time performing some experiments in lunar orbit. So this is the sort of happy anniversary to the Apollo 15 mission with several important dates kicking around in there.
Huge mission. But I just gotta say, like, justice for Al, because cannot imagine being that close to the moon and not being on it.
I know, like that would have really sucked. Honestly,
Yeah.
you're still going to the moon, but come on.
Like, what a that just would take some incredible perseverance on his part, because I cannot imagine getting that opportunity and being so close. And I know it's his specialty. Like, that's what he signed up for. He's a pilot. He had somebody has to be on the craft.
Mhm.
But man, yeah, good for him.
Yeah. There was one of the this is making me think of one of the I think it was Apollo 10, so which was the dress rehearsal for the Apollo 11 mission when
Yeah,
they did everything Apollo 11 did except land on the moon. So
yeah,
they went to the moon, they went into lunar orbit, the lunar module detached from the command module and did a little bit of a descent on the moon, but they didn't actually land. And like, oh, that would have sucked.
yeah. Like, that's just, and yeah, because all the missions have included somebody not landing on the moon or being
Yeah.
on the moon. You know what I mean?
Yeah.
And I just can't imagine not having that opportunity ever again.
Yeah.
It's of course a great opportunity regardless, but must be painful.
Yeah.
Yeah, but crazy, definitely, I think a good decision on their part to emphasize geology so much,
Hmm.
because it is something that they need to look at when they're there. They can't just be like, yeah, that's a cool rock.
Yeah. Yeah, it was actually a really big deal for Apollo 15 that they had this much geology training because before this point, the astronauts who went to the moon were like, they were test pilots, right? They weren't scientists. So this was really the first time that astronauts had gone to the moon in this sort of scientist mindset to actually start doing science on the moon. Um, so it definitely was a big deal at the time.
100%. Yeah, let's get to our last little this
Just
week in history.
quickly, I do
Um,
want to point out that the 1 meter is actually on sky right now. I think they're just trying to get to the
oh,
nebula. Um,
okay, lovely.
yeah, sorry, go ahead.
Oh, I see it. Okay, so for anybody watching our online public viewing chat room, they currently have the Ring Nebula up, broadcasted live from the 1 meter telescope. They are doing some pretty short exposures right now, so it is a little dim, but it's on the top half of the screen right now. And I think they're just workshopping it, see if they can get a better view. But definitely take a look over there. One of my favorite things to observe. Oh, here we are. That's a brighter view. Okay, so stay tuned over there. We're starting to get some color on the image. So, no, that's not color. That's just getting brighter.
Yeah,
Am
just
I mistaken? Is it
playing
color?
around with Malin Cam a bit. Yeah.
Oh,
Oh,
wow.
oh,
Okay.
there it is. There it is.
Here we are.
Yeah.
Okay, yeah. So keep an eye over there. And in the meantime, I'll tell you about something else they imaged for the first time in 1851. So this will be a quick one. We're going to get this done, get you the reminders soon. We got some exciting things to talk about. But we're talking about solar eclipses. We already kind of covered this a little earlier in the show, but a solar eclipse is basically what happens when the moon passes between the Earth and the sun, resulting in the sun casting a shadow of the moon on certain parts of the Earth. And from the Earth, it looks like the moon is covering up the sun, and you see a really cool shape. Usually they're partial, but sometimes if you're lucky, like we were this year, you can see a full solar eclipse where the moon blocks the sun entirely, and all you can see is the sun's corona around the sides of the moon. They're not super rare. Like partial solar eclipses happen all the time, but total solar eclipses are a bit more rare, and they're very exciting to see as only very small parts of the Earth will experience a total solar eclipse at any given time. So, for example, this eclipse that we just had very recently, we had Toronto itself was not in the path of the total solar eclipse. It was in the path of the partial, which is a very large range, and then a very small patch strip of land um, across a day will be in the path of the total solar eclipse because just the way the lighting works out. So, big disclaimer, I'm sure everybody heard this earlier this year, but please do not look directly at the sun during the solar eclipse because you will burn your retina. Instead, use solar eclipse glasses, which have a solar filter on them that filters out most of the light, or a pinhole camera, which is very easy to make at home. You can use a colander, you can use a hole puncher. It's super easy. You don't need anything special. This is very important, but if you're lucky and you are in the path of the total solar eclipse during totality, which is only 1 or 2 minutes, you may be able to take a look at the sun and see only the sun's corona because it gets so dark outside, it's basically nighttime. So, again, if you have a telescope, you have to make sure you have a good solar filter because it will burn the camera on the telescope and possibly ruin the lenses, and definitely burn whoever's standing behind the telescope looking through it if you do not have a solar filter on the telescope, because you need to block out as much of the light from the sun as possible to be able to view the eclipse safely. So the first ever image of a solar eclipse was taken during the eclipse of July 28th in 1851. And back then, nobody had an iPhone. It was not a camera like we're used to today. You needed a specific type of photography, a very classical type of photography called the daguerreotype process. And that was required to create images. It's a very long process. And it's basically where light sensitive silver plated copper mirrors were exposed to light in a camera, which is a camera in the traditional setting of like a box with a small opening. And then they were treated chemically for the images to appear. It took a lot of work and not a lot of people were skilled in the process. But one of these individuals, Julius Berkowski, was commissioned by the Royal Prussian Observatory at Königsberg to photograph the eclipse that day. And as well as a team of observers, the image was taken through a small telescope for an 84-second exposure. And this seems like a lot for given how bright eclipses are, but it worked because that type of photography is not very sensitive to light. You do require much longer exposures to really get that image burned onto the silver plated sheet. So this was the first ever image of a solar eclipse, and you can see what a long way we've come from all the beautiful images that we saw of the eclipse earlier this year.
Yeah, I tried taking a couple pictures of the eclipse. They came out pretty well, honestly, but I can't imagine how hard it must have been actually taking pictures of the very first eclipse with the kind of technology they had available at that time.
Basically, no technology at all. It was like super classical.
Mhm.
I want to say gadgets because that seems appropriate.
Yeah. Yeah, like it was definitely pretty hard to get the corona to come out on just the images that I took. But just photography in general, especially astrophotography, must have been like insanely hard to do at that time.
Yeah. And a lot of the records we have from that time are drawings. We don't really have images of astrophotography stuff. You know what I mean? Like all the nebulae, all the star clusters, all the constellations, especially before the 1800s, we have a lot of drawings because we had the telescopes for it and we had people who observed them all the time, but everything is in a drawing rather than a photograph. And it's actually pretty cool to see because you look at these drawings and they're so accurate to what we see today.
Mhm.
And doing that just using your naked eye or with a telescope is definitely crazy.
Oh yeah, yeah, yeah. Astrophotography is very hard, even when you have great equipment. So I just can't imagine how difficult that must have been at the time. Um,
Yeah.
but we are past the half hour at this point, so we should probably move on to our reminders. Just for anybody who's just tuning in, you're listening to York Universe, broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. Please visit our website at yorku.ca/science/observatory for chat, questions, content, or on Instagram at YorkU Observatory. Tonight you're listening to myself, Sana, and Gagan, and we've currently been discussing some This Week in Astronomy history topics, including Apollo 15 and some the very first images of a solar eclipse. We're also doing some live imaging with the 1 meter telescope. We are just on the Ring Nebula a minute ago and are actually going to be moving to the Wizard Nebula next. So if you'd like to see some live images from the 1 meter telescope, please head over to our YouTube channel that you can get to through our website, yorku.ca/science/observatory. So we do have a couple of just reminders coming up for the next week or so. First of all, we have an in-person tour of the observatory coming up on Wednesday. We're going to be in the actual observatory itself this time, not on the atrium like we are a lot in the summers. So if you'd like to come see the 60 centimeter and 1 meter telescopes in person, please join us on Wednesday. Also, the forecast for Wednesday is looking nice and clear, so hopefully we'll be able to do some live imaging. These tours are free, but we do ask that you sign up ahead of time so we know how many people are going to be coming. There's not a ton of space in the observatory, so we do need to limit the number of people who can go up there at the same time. So please get tickets ahead of time. You can do this on our website, yorku.ca/science/observatory. The links should be on the first page. And Gagan, you have a couple reminders for us too.
Yeah. So in addition to the observatory tour this Wednesday, on July 31st, there are a bunch of really cool astronomical events happening this week that you should keep your eyes peeled for. The first thing being potential aurora sighting in the next couple of days. We are going to be experiencing a G3, which is a relatively strong geomagnetic storm, tomorrow, and then G2, which is a moderate geomagnetic storm on July 31st and August 1st. And this could bring another chance of aurora. So we had some great aurora sightings as far south as like Hawaii earlier this year. And hopefully we'll get some more aurora sightings. So if you are anywhere with a clear sky, definitely check out aurora sightings websites. And there's a free aurora app that will give you alerts if you have aurora sightings in your area. So that would be definitely a very cool thing to see. The other thing we have coming up are two different meteor showers, both of them peaking on July 31st. So if you're really lucky, you can get like four amazing things. You'll get the observatory tour, two meteor showers, and then an aurora. So fingers crossed for any astronomers looking up on those days. So the two meteor showers that we have coming up are the Southern Delta Aquarids. These are fast, small, and frequent, and the Alpha Capricornids, which are slow, a lot bigger. So you might get a few fireballs with this meteor shower, but they are few and far between. You might only get a few meteors per hour, whereas you might get a lot more with the Southern Delta Aquarids. So both of these showers are peaking on the 30th, 31st, and 1st. So if you're really lucky, you might be able to spend some time and catch a few shooting stars. Just some quick tips for viewing. I find a nice empty dark sky. See if you can camp out for at least an hour, because for the first half an hour, try and don't look at your phone, don't look at any white light sources, because you really want to let your eyes adjust to the night sky and adjust to that night vision. You might have to be there for a while. The longest I've spent outside on a meteor shower viewing is like 2 to 3 hours, but it is so worth it because we always come away with some great sightings at the end of the night. So let your eyes adjust for at least 15 to 20 minutes and then just camp out and stare at the sky. Bring your friends with you, bring some hot chocolate, bring a blanket. It'll be a great time. And if you're lucky with the timing, you might get an aurora too. So enjoy. It's going to be a great night for observing for any casual astronomers in the area.
Yeah, that'd be awesome, getting a meteor shower and aurora on the same night. Um, One thing I do want to point out about the aurora that I didn't fully appreciate last time is if you're outside and you don't see any aurora, try taking a longer exposure picture with your phone, because apparently sometimes it shows up in a cell phone picture, but it's hard to see with the naked eye. That's what I've heard from a couple of people.
Yeah, another quick thing about the aurora in that same vein is that it kind of, when you look out at the night sky, an aurora might look, especially if you're in a very light polluted area like we are, like really close to Toronto, the aurora might just look like some clouds. But then if you sit there and look at it for more than a minute, you'll see that it's moving, it's dynamic, it's not um, and not in the way that a cloud would be moving. So definitely you'll get more color with your phone. You won't really get the bright colors with the naked eye unless you're in a very dark area. But definitely keep your eyes peeled. Try using your phone, or if you even have a better camera with longer exposures, you might be able to get some really nice photos and videos.
Yeah. Yeah, I remember last
Okay.
time we had this.
Oh, sorry.
Sorry. No, I was just gonna say, I remember the last time we had this, I tried to spot the aurora, but it was kind of cloudy, so I didn't see anything and probably went back inside a little bit too soon because it was just like I figured it's cloudy, it's kind of hopeless because I live in a pretty light polluted area. But I think this time I'm gonna spend a little bit of time sitting outside trying to spot these things because it is possible, but fingers crossed.
Definitely possible. Yeah. I was able to see it from my driveway in Brampton, which is,
Oh
I
my,
do not live out in the outskirts. I live in the city. I live in like street lights, like people. Um, this is something super annoying, very small thing. Nobody knows where I live, so I'm not doxing anybody. But the people that live on three sides of me keep their pot lights on all night.
hmm,
And I'm the type of person that sleeps in the pitch black. And I'm also the type of person that likes to do observing at night when I take my dog out. And it is such a pain because I'm like trying to image these aurorae and I'm getting a great view. I was still able to see it, but there were pot lights on, like bright white lights all around me. It was like I was in a stadium. So the aurora can still be pretty bright. I was still able to see it despite all of that light pollution. So you don't need to be too rural to get a view.
yeah. So fingers crossed for clear skies, and hopefully we get to see some aurora. Um,
Yeah. Do you want to
uh,
get us started with our news item? I think
yeah,
this will be our last
in
topic
our
for today.
last 10 minutes, we will talk
Yeah,
about these items. There's just too many fun things to talk about in astronomy.
seriously.
So yeah, one of the things I thought I'd talk about this week is Boeing's Starliner. So Boeing has been having some problems with some of their aircraft more recently, and also now with some of their spacecraft. So NASA has this commercial crew program where are now under contract with both SpaceX and Boeing for them to create these reusable capsules that can do crew rotations for the International Space Station. Uh, SpaceX has been at this for a while now. They've had multiple, I think, 8 different crew rotations to the International Space Station under contract for NASA. They are amping up to do their 9th crew rotation under the Crew 9 program. But Boeing is a little bit behind the SpaceX commercial crew launches because they are in the middle of their first crewed test flight to the International Space Station using the Starliner capsule. Now, I've been pretty excited about the Starliner capsule for a while. It's a really cool spacecraft, but unfortunately, Starliner has just been running into a lot of problems like almost every step of the way. They had a couple uncrewed test flights. The first uncrewed test flight to the International Space Station was in 2009 that unfortunately didn't actually reach the ISS. It was able to safely land on the Earth, but it just didn't actually reach the ISS itself. Then they had a second uncrewed test flight in 2020, which was a wild success. Reached the International Space Station well, landed back on the ground well. So it really sort of set the stage for what they're currently doing right now, which is a crewed mission to the International Space Station, really just meant to be a sort of crewed test flight to make sure that Starliner can actually safely carry human beings to the moon. So this crewed test flight for Starliner had only 2 astronauts on board, where I believe the crew rotations are supposed to have 4 astronauts. At least that's the way it works on the SpaceX flights, where they had astronauts Suni Williams and Butch Wilmore, both NASA astronauts, who were originally supposed to spend 10 days on the International Space Station from Boeing's Starliner. But they have now been stuck on the International Space Station for 55 days because Starliner has had some problems. The Starliner problems started all the way before launch. They were originally supposed to launch on sorry, I think it was about a month. The launch was delayed for around a month. Yeah. They launched on June 5th, reached the International Space Station safely on June 6th, but they were actually supposed to launch a month before that date, and the launch date just kept getting delayed. A couple of the bigger issues that Starliner was running into is that they had some small helium leaks in the spacecraft. And they also had some issues with some of the thrusters. I think Starliner has 28 thrusters in total, and they were having a couple issues with 5 of them, which had delayed the launch. Eventually, engineers from NASA and Boeing determined that they could safely launch to the International Space Station, which they did. The launch went well, docking to the ISS went well. But now that they are on the International Space Station, they have discovered some more problems, primarily with the helium leaks and with the thrusters, that have caused NASA and Boeing to decide that it's better for the astronauts to just stay on the ISS for a bit for now. And then while they troubleshoot the problems and when they figure out what's wrong, then they can return the astronauts to the Earth. So I've been seeing a lot of headlines about astronauts being stranded at the International Space Station. A lot of these headlines are a little bit dramatic. They are not stranded there. They will be perfectly fine. They will very likely be able to return to the Earth on the Boeing Starliner capsule, but of course, they will figure something else out even if they can't. So the astronauts are doing perfectly fine on the International Space Station. I think if I was an astronaut, I would be glad to be on the International Space Station for a longer period of time, getting a nice mission extension, some more days in space. So everybody, the astronauts Suni Williams and Butch Wilmore are fine on the ISS, will hopefully be returning to the Earth soon. The sort of reason for this news item was that a couple days ago, they actually did some tests on the thrusters on Starliner while it was still attached to the ISS, which has sort of just shown that all of the thrusters are working well, they are operating well. So we'll likely be able to have the astronauts return to the Earth sometime in August. So definitely very delayed, but not crazy delayed. And they will hopefully be back on the Earth soon. There were also some ground tests that discovered some of the reasons why the thrusters were having issues, which mainly just had to do with the fact that some of the insulation around the thrusters was overheating when the thrusters were fired repeatedly for short periods of time, which they need to be in, which needs to happen in space. When it overheats, it causes the thrusters to sort of shed this Teflon insulation that surrounds them, which is what's ultimately been causing problems for the thrusters. And they also pointed out that this was not an issue that could have ever been discovered on the ground with ground testing. This really is one of the issues that you only would have seen when you were actually in space using the thrusters trying to dock to the International Space Station. So definitely a bit of a saga with Boeing's Starliner, but there is an end in sight. Hopefully the ISS astronauts will be returning to Earth soon after a nice, I guess you can call it mission extension at the International Space Station. And looking forward with Starliner, they are actually supposed to do their first crew rotation, the Starliner 1 mission, in August of 2025, where astronauts will stay at the International Space Station for 6 months, which is really the standard amount of time that astronauts stay at the ISS during a crew rotation. So yeah, another little update on Starliner, and hopefully in a few weeks we're doing an update that they safely returned to the Earth. Gagan, are you there?
Oh, so sorry. I completely forgot to unmute. I was just talking to nobody. I was just gonna say, I was just saying, I was talking for like a whole 10 seconds before you
Oh my
called
God,
me out.
I've done that before. That's just the joys of Zoom, right?
Oh, so many times. Yeah, I was just gonna say, definitely a little bit blown out of proportion. It is worrying that they do have a handle on these issues. I'm sure they know how to fix it, despite all of Boeing's current goings on. Um, but yeah, they definitely keep food on the ISS for a long time because
Yeah.
for this very situation, you never want an astronaut on the ISS to run out of food. They have ample storage of food,
Oh
and
yeah.
they can always send out more.
Oh yeah,
That's a
absolutely.
pretty easy mission for them to do.
Yeah, I definitely like I understand that this is maybe not an ideal situation, but I find a lot of the time with things like this, there are certain certain websites specifically that tend to blow it out of proportion. And sometimes when I look on sort of news feeds, I've been seeing a lot of these like attention grabbing headlines about, oh my God, they're stuck on the ISS, but it's fine. They're totally cool. Just
Yeah.
chilling on the ISS, which is fun. Um,
Yeah, hanging out. It's a great time.
yeah, anyways, we are at the top of the hour. Hopefully we're enjoying a couple views from the 1 meter on the Eagle Nebula, which is no, they're on the Omega Nebula right now. So hopefully getting some last views of that. But you've been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Gagan and myself, Sana. You can always connect with us on Instagram with the handle at YorkU Observatory and on Facebook at Allan I. Carswell Obs. You can also visit our website, yorku.ca/science/observatory, to check out our show notes, content updates, and contact info. Thanks for tuning into York Universe, clear skies, and have